Okay, folks, let's get started. And just for information, this event will be live on YouTube as well. And today's meetup, it's all about automation, DevOps, and cloud for the newbies. So the way we do all this webinars is I call upon industry experts to talk on the specific topics so that we can all learn together. I myself, I work as an independent consultant working with big data and tools and technologies. And very recently, I worked with one of our panelists, Chandan Kumar, who is going to present today about simplifying the world of DevOps, cloud, and automation. So while working on a critical enterprise solution, the need was to automate testing, building the code, and deploying it in various environments. Because the financial institution that I was working with, Chandan, they were having issues with the frequent releases of their code in the production environment because of the so many systems involved. They were not able to do frequent builds and deploy it, especially automatically. So I got a chance to work with Chandan, and trust me, folks, he simplified the solution to such an extent that nowadays the same financial institution is having frequent releases in production environment. And whenever you call it, like, okay, you want to do a build, test, and deploy, fine. Just a click of a button, you are able to release the code right from the developer's environment to the production environment. To talk further, let's not any time and call upon Chandan Kumar to present simplifying the world of DevOps, cloud, and automation. It says for newbies, but I would say even if you are an expert in the same field, this talk is worth listening. Let's call upon our presenter for today, Chandan Kumar. Chandan, can you please take over?
Thanks, Hiren. Can everybody hear me?
Yep.
Okay, sounds good. So today we'll talk a little bit about DevOps, and thanks, Hiren, for the kind words. But just want to add that this was not me alone who was doing it. Hiren was equally 50% partner on the Agile delivery model that we delivered. So he's equally capable of it. He's just kind enough to give me the opportunity to talk. And I'm really thankful for that. And for the folks who have joined from YouTube and from Toronto AI Meetup, feel free to post questions on the YouTube channel and we'll respond to you after during the Q&A section. So let's start without wasting time. What is DevOps? So I hope some people, whoever has signed up for this event, they at least know something about what is DevOps and everything. So I'll go a little bit about basics and then we'll start about this. So today, the agenda is like overview of DevOps, what it is exactly. Then we'll touch base upon a little bit more on DevOps versus system administration, which has been traditionally, because a lot of people with the system administration background, they are now moving to DevOps. And then evolution of DevOps, what actually is driving DevOps, what has led to the current state of DevOps. And then I will talk about some technology comparison, like a lot of buzzword here, right? Jenkins, Terraform, Ansible, Puppet, and everything. We'll just do a side-by-side comparison. And end of it, we'll do a quick demo on Ansible with Amazon Web Services. So DevOps, the word DevOps is, there is no like a word, like it's not a science word or anything. It's not like a first law of thermodynamics, second law of thermodynamics. This is a mostly industry, or I will say marketing term used over a period of time. It involves a lot of activity. If you see this diagram from Wikipedia, it shows DevOps, means development operation. The job of a development operation is that you take the whatever operation you do for a software delivery, like software development. If anybody worked in a software company, you know there is a cycle, like developer checks in the code, they need to compile the code, then you need to do some unit testing, integration testing, and then it goes to operation side. Like you have to do release management, configuration management, and monitoring once you deploy into production. So if you take the whole concept as a one giant software project, imagine that is what is DevOps. You take the whole thing, and whatever operation you're doing for a development operation, you take that approach from a software developer approach, in the sense that the whole operation, like someone is checking in the code and compiling it, this process, I'm not talking about the application itself, I'm talking the process of this doing. If you take a software development approach to solve this problem, it means API driven solution. The moment someone does a check-in, you call a webhook and trigger some kind of task. So in that way, it is more and more nowadays people are using DevOps term. And again, when it comes to DevOps, a lot of people are still confused about why we need this to begin with, why it is there. I mean, people have been doing software development for more than 50 years. And by the way, it has always been there, but the modern form of hasn't taken place due to a few driving factors that I will touch base upon. One primary driving factor is that Agile development. What happened was, in late 90s and 2000, this new software delivery model started coming in. Before that, we all was using waterfall model. Waterfall model is what? You take a software, you do a requirement analysis, and then you do a design document, and then you start writing code, and then you do the testing. So this is a typical called waterfall model. What happened was that over a period of time, the requirements started changing so fast that people didn't have time to go back and forth. Second thing was the software delivery cycle became too quick. For an example, I will say, if you go to Facebook today, and if you just log in Facebook, say after maybe 2 weeks, you see a lot of UI, small here and there, it changes. Why it happens? Because Facebook, they are updating their application all the time. It's no longer the case that you usually used to hear. I will say, still you will see government website. Mostly they say we are going to do an upgrade. 2 days CRA website will be down, because they are still not following the Agile approach. They are still more or less, I will say, SDLC approach, in that they do a big bang upgrade in one shot. So it's nothing about wrong or right. It is just a different way of approach. If you want a very fast delivery, then people like to use Agile methodology. Agile methodology is like you have dramatic changes in software delivery mode. So that's why I said, now instead of delivering a software once in a year, you are delivering the software to production probably weekly or a monthly basis. Fast-paced development and Agile-based SDLC. So it's the same thing. You have Agile. I'll talk a little bit about Agile in the next slide, just to give a background if anybody's not from a software background. Because most people who are from a sysadmin or system or IT background, they really haven't done any software development. So they may not know why we have Agile and how it adds any value. Second is that small and incremental changes. It means when you start any Agile-based delivery, you don't actually create a massive requirement. What you do, you say, take an example of your website. You create a small requirement. I want to change this button. I want to start an e-commerce website, maybe start a button. So one button at a time. And I will deliver it on production, and we'll see how the market responds, and we'll get the feedback, and I'll do the next round. So this is called incremental and fast delivery. Release cycle changed from yearly to weekly, as I mentioned. What happened was it put a tremendous pressure on the development pipeline. What I say development pipeline, historically, whenever a developer used to develop any code and deliver, it used to be an army of QA guys and sysadmin and configuration management. They will sit day and night to make sure the code is delivered into production. It was a massive work. And I have been through that. 10, 15 years ago, we used to do that. STP1, STP2, you basically whole 2 months we are doing delivery. And imagine if you have to do delivery every week, you cannot afford to have that. It's too costly and it's just not feasible. So the only solution for this problem is you have to automate the whole thing. There is no other way that you need a human intervention for a QA testing or even for delivery. And what happened was it led to an end-to-end automation. This is, I'm talking about driving force from a software development cycle. So this is your SDLC approach. The quick, I said, you do requirement analysis, you do the design document, you do the actual software development. The software developer actually comes into this picture, and then you do the testing. So what happens is many of the time, software developer doesn't get the right requirement because it come through many channels, and by the time he or she get whatever requirement, they understand something else and they deliver something else. So when it goes to a testing cycle, because tester knows what is exactly the requirement, it often doesn't match. So there are a lot of back and forth in development testing. It actually delays the whole thing. Here we come to Agile. In Agile, this I'm giving you a very simplified Agile. It's not the full Agile manifesto, but it's just a basic Agile that what you do is your requirement, fundamental thing you assume in Agile is that your requirement is constantly changing. So what you do is that you take a piece of requirement and do the whole software development lifecycle, and you call this, depending upon what kind of Agile methodology you follow, maybe Kanban or Sprint. So what you do is that you take one thing and you do a one sprint. Sprint could be 1 week or could be 2 weeks. So basically, each time you do a small delivery each time, and you deploy in production and get a feedback. This gives you a very good understanding of what is going on. So this is the key for driving force for DevOps, because now when you have every bi-weekly or 2-weekly delivery, you cannot have an army of QA or a sysadmin to deploy. No, you need to have completely automation. So automation, you could use any tools. I've often see people they are often fixated on the tools. Hey, I want to learn Jenkins. Hey, I want to learn Ansible. No, forget about tools. Tools will come and go. See, in past my 15 years, I have seen many tools, their heydays, and they just gone like anything. So focus on the concept, but the concept and these fundamental concepts remain the same. Tool will come and go. So you have to understand why DevOps came into picture in the current shape. And the second driving force I see is from the infrastructure side. So there are two phases of DevOps anytime. One is the supporting the development operation, and second is the supporting the full automation of your infrastructure. So what happened is, quick example, long time ago, you used to have one physical server, and basically that's it. One sysadmin will manage it. Then virtual machines came around in 90s and 2000, and now there is an explosion of containers. So right now I'm talking about in microservice, even for a simple web service, like if I'm talking about your WordPress website, LAMP stack, Apache, MySQL, Linux, pretty much you're talking about at least 10 to 20 containers. And imagine if you try to maintain those containers in your old methodology, it's just impossible for someone to manage. So complexity in infrastructure side has gone up dramatically. And on the data center side, before you had one data center, right? You log in and you do everything. Basically a bunch of sysadmin, they will restart something. But now we're talking on the cloud. Cloud in the sense, cloud is a fancy word of saying a public data center. It's just a very fancy way of saying it means someone else is hosting the data center for you, and you pay them as you go in a various cloud delivery model. It could be a PaaS, it could be a PaaS mean platform as service, or infrastructure as service, or a software as service. Very simple example, your Gmail is a software as service. As simple as that. You don't own anything. You don't care where the emails is stored, as long as you have access to your email. Similar way, infrastructure as service as you rent virtual machines or containers on Amazon or Azure. And platform as service could be your Cloud Foundry. These kind of solution. So these are two driving factors I talked about. And so in the current form of DevOps, and if you see the usual or average salary of DevOps is usually more than any of these people working. The reason is that it's not that DevOps is something new jewel. As a DevOps engineer, you're supposed to wear multiple hats. You have to understand what is configuration management. It means you have to understand Git workflow, Git based, or any kind of software control system. So anybody without any software development background, they won't know what it's all about. Second is system admin. You have to be a good system administrator. Doesn't matter Linux and Windows, because nowadays we are talking about very heterogeneous platform. So you have to be, at least, I'm not saying you have to be Superman or Superwoman. You have to be just understand what is the problem. That is the bottom line. Because before you Google a problem, you have to know what is the problem. You cannot just copy paste the error and expect magic. Because Google, you have to tell what you're looking for. And I see often people, they struggle to find the problem. I mean, they just paste in Google and they spend hours and hours, they won't find it. So why? Because you do not know the problem. Second is you have to be a build engineer. Build engineer means you have to understand what is Maven, first of all, you have to understand what is compiled language and what is uncompiled language. Like Java is a compiled language, Python is a scripting language. Similar way, C, C++ is a compiled language. And so some people talking, oh, yeah, I want to learn Maven. No, you don't want to learn Maven. You have to understand which programming language. If you go to a C++ shop, they don't use Maven at all. They use GCC compiler. So you are, oh, what is this GCC? So first, just understand the basic. If you have any compiled language, you need a compilation tool. It could be Maven, it could be GCC, it could be Gradle. Most cases, people use Java, but doesn't mean Java is all the king. So there's still high performance softwares are always written in C and C++. You have to understand test automation. You don't have to be a tester. Remember, tester is someone who will design the test cases, and your job is to actually write an application or some kind of automation around the test, so that whenever the build trigger is happening, you are able to automatically trigger the test, and outcome of the test can be somehow fed into some kind of report, or maybe you can send an email to the test guy, something like that. Production deployment, you have to have a understanding what is production deployment, do the deployment, and second, the most critical thing from my IC is the monitoring and alerting. Because as an infrastructure guy, if you do not have monitoring and alerting, everything is failed. Because unless if something is down, you should know before your customer knows. So it is very bad if customer says, hey, your website is down. No, it's bad. You should know before, and you can send an email to your consumers, okay, this is down, we know this problem is there, and we are fixing on it. It gives you a sense of comfort to the end user. And last thing, which most people are scared of doing it, they think I'll lose job, but is not the case. You will do something much more better. Basically, replace him or herself, because you do something, you completely automate and just do on some other project, unless you want to repetitively do the same task over and over again. So when I talk about DevOps, you have these kind of job roles I'm talking about: Linux admin, configuration management, build engineer. You have to be a developer. Yes, you have to be a developer. You don't have to be a Java or a Rockstar developer. Even a Bash development or simple knowing Ansible scripting, or could be a Python, is very good asset. And platform operation orchestration. So any kind of platform orchestration, you have to be able to come to comfortably. And here is the mostly buzzwords. I may have missed some buzzword. There are every day are being created. So whenever I'm talking about any kind of a DevOps pipeline, there is always certain stages. One is your provisioning, and then you have provisioning tools. Means anytime you're talking about cloud, you are talking about you have to create an infrastructure first, right? Assume if I didn't have this PC, I couldn't even deliver this presentation. So for anything, you have to create a PC or something. So in this world, we call creating either virtual machines or maybe creating whole platform, or it could be containers. So these are the tools that you can use. You can use Terraform, Ansible, Puppet, Sard, CloudFormation is for Amazon, AWS. So again, none of these tools I will say bad or good. All tools have their own place in the whole big stack. If someone, if you're fighting like this, hey, this is better. I mean, okay, in a college debate, you can fight very nicely. But in real world, if you see, you can do everything with any of the tool. You can do everything with Terraform. You can do everything with Ansible. But at some point, you have to do some kind of trade-off. In that case, you have to be a real judgmental. So I'll do a quick comparison on the first slide, like this one, provisioning section on the next slide, just to give an understanding. And then you're talking about infrastructure as service providers. So you could have a soft layer, you could have AWS, OpenStack, VMware, Azure, DigitalOcean, Google Cloud Compute. These are all your public cloud providers. Mean they are public data centers. So they provide you all kind of infrastructure and compute power and storage power as a rental service. So you pay as long as you're using their service, you pay. The moment you stop using service, you stop paying. Coming back to PaaS, which is your platform as service, it could be your Hadoop, it could be your Cloud Foundry. Pivotal Cloud Foundry is being very popular. IBM Bluemix is built on top of Cloud Foundry, and there are Amazon has millions of PaaS, and same with Azure also. Like you can say Azure IoT platform is a PaaS service itself. And then it comes to configuration management. And what is configuration management? Actually, configuration management is a very simple thing. Assume you install anybody. If you install some website, assume like WordPress, your blog is working fine. And what happens if someone asks you, hey, can you create another blog similarly? So what you will do? Will you do the steps all over again to do that? No, if you have a configuration management software, what you do, you write a software or write an application or a script to install and set up that website at once. And if the next time the same task comes to you, you just run that script again and it will do the exactly same thing without any brain. So any repetitive task you think that you can automate, this is where the configuration management thing comes. But if you think something is you're going to do once in a lifetime, no, there is no point of actually writing a code if you're never going to repeat that thing. So configuration management comes at this stage. And also sometimes, see, people want to have compliance. You want to have my software up to date all the time. So in that way, you can have a configuration management script written in such a way that every night you'll check your update. If there is any update, it will install. Or maybe if someone by mistake deleted a package, by mistake, some system and a new guy coming and deleted something. So configuration management software will be able to detect that change and revert those changes. So that is another very powerful feature. Any questions so far? And feel free to make it interactive. I mean, there is nothing, you can just unmute and start talking. You can leave a comment on the YouTube text box. And here we will talk a little bit about difference between some of these. This is a very old and very, heated discussion about in the community, like which tool to use, which tool not to use. I have a different take on that. I think that in the modern platform, pretty much you need more than one configuration management to manage. So I like to, I have taken these four. These are one of the four most popular ones. They are pretty much every day new coming up. So Ansible, Puppet, SaltStack, and Chef. So these I will say four. So there are a few things about this configuration management. Ansible is a language, if you see on the left side. So it's a very simple and it's a very client-less solution. It means you do not need to install any client. You just have very basic YAML script. We'll do some Ansible demo after this. And you can basically do whatever you want. Whatever configuration management software wants you to do, you can achieve that objective. So positive about it is very simple, very easy to learn, especially for someone with no programming background. Because if you haven't written any code in your life, believe me, it takes some time to write your first code on your own. You can ask anybody, you can ask Hiren or anybody who is doing for 20-25 year development. But whenever the first time they wrote the code, it was really painful. And same with me. It took me 3 months to write the first C program. So, I mean, that was the situation. And same way, but if you have no programming background, it is very easy to learn because it's not a programming language. It is a YAML file. YAML is a very simple document-based file. It is. So it's very easy to use and we have very large community. It's good. Second thing comes to Puppet. Puppet is actually, I think it was inspired from Chef. So it is a Ruby-based framework. And it is a very comprehensive configuration management. So it has both modes. One is like client server mode or server only mode. So client server mode in the sense that you install a client on the machines and the client will run every, say, 1 hour or every nightly and connect with the server to make sure if what server wants the configuration of this guy, if it matches or not. If it doesn't matches, is undo all the changes that has been done manually. And this is a very powerful feature. And I think a few weeks back, one of my friend called, he was saying that they had almost 1,000 servers somewhere and they were running Ansible. So with Ansible, what is good that you can push in a large amount of server. But what if someone pushed a wrong code? Say if someone pushed something wrong and because Ansible uses SSH, if the SSH is broken on that box, you're done. You cannot do anything on the remote box anymore. In that kind of scenario, Puppet is very powerful because if you break the box for some reason, and if it is fixable by Puppet, Puppet will ensure it will fix the library and your machine will be back online. So depending on use case, you may have to choose carefully. So again, Puppet is a client-server model. Now it supports server-only model as well. It's written in Ruby. Some people don't like Ruby, some people like Ruby. So it's completely up to your personal choice. Of course, large community enterprise support is there, and it has some learning curve. It is not like you cannot be like Ansible. Usually, I've seen people pick up in 4 to 6 weeks. They are able to pick it up and able to modify the existing code, and over 3 months of period, they can be a self-sufficient Ansible coder that I have seen in past. So, but in Puppet, it's not the case. It will take learning curve is a little bit more, and person to person, it could be between 3 to 6 months. Salt Stack is a similar concept. It's completely written in Python. It all in YAML, and also has client server and server only mode. Of course, it has similar learning curve as Puppet, so it is not as easy as Ansible. And last one is Chef. Chef is the most highly scalable. I think it is used in heavily inside AWS. For only reason, it is very complex. Imagine what is very complex. It means its capabilities are also great. Because if something is very easy, its capabilities are also limited. So just think of it something. If there is something really easy task to do, will you get paid more for it? No, because anybody can do. If something is really complex to do, of course, learning curve will be hard, but you will achieve more. So again, depending upon your use case, you can pick it up. So if someone is completely new to it, I will say start with Ansible, and then just as and when requirement comes in. And many cases, you may not need Puppet as well if you are having a public cloud infrastructure. So this is a quick comparison on that. And so this is the thing about like automation. So basically, your goal is that you improve your performance using automating everything. And so this is a few DevOps and configuration management side by side. So in DevOps world, what are tool stack you use? You do build automation, you do test automation, you do branching strategy, you do artifact deployment. It's on the development cycle. Tools, Jenkins.
Chandan?
Yeah.
Yeah, hi. Ashi has a question. So I think I agree on that question. I also wanted to ask.
What is the question?
Yeah, the question is it mandatory to have knowledge of all these configuration management tools, or having experience in Ansible is good enough for someone who is very new in the DevOps? I think that's the question which resonates with all of us. Can you please throw some light?
Yeah, so yes, Ansible is more than enough. As I said, you don't have to learn everything. What you do is, right now Ansible is hottest in the market because it's easy to use. People are getting on board very quickly. So you can start with Ansible, and then take an example. I used to do Puppet 3 years ago, and I haven't used Puppet in past 3 years at all. So it may be possible you may never have to use anything other than Ansible till the time Ansible itself retires, and then nobody guarantees about technology, right? So right now, I think if you want to get your hands into this world, especially configuration management DevOps, I say Ansible is a good choice for someone who just want to start, and try it for a few years. And then basically, depending on use case, some people, many organization, if they are looking for I think I didn't cover this one, maybe next time we'll cover. It's like two types of infrastructure are there. One is we call cattle approach, one is a pet approach. It means cattle approach of infrastructure is that you install a box and you take care of it for rest of its life. So it's like a pet. Like if the infrastructure has gone bad, something has gone bad, you go to fix it. So these kind of approach, if you want to have any infrastructure, simple example, say your website. Yeah, you want to have your website up and running and you don't want to restart or anything. So in that kind of approach, you will use any kind of application like Puppet is a very good solution for that, because it will keep it healthy. It will keep give you vitamins and protein and everything, minerals, so to keep the machine and the environment healthy. But another side approach is a cattle approach. Cattle approach is that which is now getting very, very popular with microservice. Kubernetes, Docker, you must be heard of all these things. So in that approach, what you do is, if something goes wrong with your service or anything, you don't fix it. You just kill it and start a new one. Troubleshooting you do later on. You don't care about it. You after on, developer will do whatever is do. So in that kind of approach, Ansible is very good and very popular. And this is one of the reasons, because Microsoft is getting very popular among developer community and also enterprise. So people want more of a cattle-based approach. So say we create a box in Amazon. If it doesn't work, I just kill it. I don't care. I don't fix it. Create a new box. So in that approach, I will say Ansible is more powerful. So if you are starting to, coming back to your question, Ansible is your choice to go right now. Does that answer your question?
Yeah, Thank you.
Okay. So this is coming back to this DevOps and configuration management. So in the DevOps side, toolchain stack I'm talking about, say, this Jenkins, Maven, Gradle. These are most popular for Java world. And on the configuration management side, we have Puppet, Chef, and Ansible. So coming back to the technology stack that I had, this one, if I go back here, yeah. So if you see here, you can see here. So in provisioning and configuration management, see, there are so many tools. You can pick any one and you can achieve your objective. If someone is saying that something cannot be done in Ansible, probably they don't know Ansible. Again, someone says this cannot be done in Puppet, they don't know a Puppet. Every tool is equally capable, but I will say starting point, Ansible is very easy because it doesn't require any programming experience. So coming back to this, and I think that's it for me. Any question so far? Because I want to keep it quick, and the reason is that I don't want to move too fast, and at the same time, I didn't want to have too long presentation because sometimes it gets boring because I cannot see anybody's face, if anybody's sleeping or not. So I will say just feel free to question. You can just unmute yourself and ask question or leave a comment on the YouTube.
Hey, Chandan.
Yeah, hi. Who's this?
It's me, Ashi Chandan.
Hi.
Hi. So just a quick question. Can you also cover the architecture perspective in terms of DevOps? For example, like I said, I have been an established systems engineer working on cloud as well. But when it comes to implementing a DevOps infrastructure or architecture in a team, I'd like to know where to start with. Like, I mean, in terms of scaling the infrastructure and on which infrastructure should I install, or on which VM should I install the, for example, if I'm adopting Ansible in the project, or on which infrastructure should I use, like OpenStack, for example, or like GitHub, you know what I mean? Like
yeah, so see,
kind of knowledge I'm looking for.
Yeah, so there are a lot of stuff around here. So see, as you said, OpenStack is an infrastructure as service, and it is a very, very complex software. You won't be able to understand OpenStack, and don't even try to understand OpenStack because it is just too complex. So what you can do best is, if you work somewhere where they're using OpenStack, you should be able to understand the API. But again, nowadays people don't even bother that much complexity. Say if you just want to play with the infrastructure, I will say start with your Amazon. AWS is a very easy tool. So I will just do a quick demo on that. So you talked about few things, right? You said, okay, GitHub, Ansible, and this. So GitHub is what it is a source control system. So you can control your source code. So take an example here. I'll show you. This is my GitHub repository. So this is a GitHub repository. I have kept this Ansible code here. And this one anybody can download. It's open source. It's free. So you can download the code. And with that Ansible code, I'll be able to say I want to create infrastructure in Amazon. Say this is my AWS box. This looks like. Say I have right now on one VM. And I want to say I can just delete it, okay? So let's delete this one. So I have no. And if I want to create say Amazon T2 Micro. T2 Micro is their one of the smallest VM, which is also eligible for free tier. So there are many ways. So a lot of people say they are DevOps, but actually they are doing WebOps. WebOps in the sense, you see a lot of people are doing certification, Amazon certified, this certified, this certified. So these guys they're not necessarily very handy developer, but yes, they are very good at understanding the product layout of the Amazon. So if you ask them to do anything on Amazon, they will click on this button, this button, this button, and they will get the environment ready. But again, when it comes to troubleshooting, or can you just scale it or automate it, they may or may not be able to do it, because troubleshooting will require you to have good networking and Linux hands-on experience, which not everybody seems to have. Second thing is that if someone talk about, hey, can you just scale it? Can you spin up 2 VMs right now and just install WordPress on it? In that one, they will do click here, or they can use a CloudFormation, which is again very Amazon specific, your infrastructure as code example. Nothing wrong with that. It's great. Amazon is so hot. But the problem what I see is if you're too much fixated with Amazon, if someone says, okay, I'm not going to use Amazon, I'm going to use, say, GCP or Azure, and then what will happen? You are done, right? You don't know. And if you have learned very specific to one cloud environment, adopting to something, sometimes it becomes challenging. I'm not saying they're completely different. Actually, they are very similar. So it's good to have DevOps knowledge. Like I can create a VM, like I can click on this button, I can create. But if you want to make it automated and scalable, you should be able to create it programmatically. And every public cloud service does give you these things. So take an example of creating an EC2 box in Ansible is as simple as that. It's a very simple. See, there is no programming language. It's a very document driven. So I say create. This is just a debug statement, and I give say there are some keys. I can explain later on what is this. So you have to define firewall rules and SSH keys, and I tell him what I say. I want a T2 micro, and I give the AMI. AMI is the image ID in Amazon world. It's called image ID, and I want this type of image to be instantiated, and I'm giving the region as Canada Central 1. Which is I think in Montreal. Okay. So now if I take this code and I just run it, what it does is now it's connecting to Amazon using their Amazon Boto library. And then if you see here, if I refresh it here, see it's creating a new instance. So now this is a very, someone is doing what beep beep sound is coming. I don't know. If someone is calling or what?
No, even I get it.
I think lower hand.
Udasana maybe, I'm not sure, but so like I said, you have currently created the instance, AWS instance using the Ansible application, which you have installed on your Mac.
Yeah.
Right.
And now say if you want to, you can do more. Ansible you can install anywhere. You can install in Windows, I don't know, but Linux you can install also. And same way, I think this one is you have say, what is this sound is coming?
Okay.
Wait 1 minute. Okay, so I think sound is gone for some reason. So this is a very simple example that I'm saying, okay, we can use EC2. But again, once you are a little bit comfortable with Ansible, if someone asks you to deploy a, say, WordPress, or maybe deploy a Hadoop. So if you want to deploy a full Hotmux Hadoop, or you want to deploy a Apache Kafka or Elasticsearch, you can basically create roles and boom, 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 one after another. In 10-15 minutes, you have whole cluster ready. So you can have some kind of infrastructure as code kind of feature where any repetitive task you can do that. And the beauty of doing it that if you do it instead of using Amazon CloudFormation or using click WebOps kind of style, in that way you are learning a new tool. That knowledge can be transferable to any other public or private cloud as well. If tomorrow your organization says, okay, we don't want Amazon, maybe we still want Amazon, but we want to have a hybrid cloud that most people are nowadays talking about. Hybrid cloud is a situation where you have half of the stuff is on-prem and half of the stuff in public cloud. So in that kind of scenario, Ansible is very powerful. You can actually instantiate stuff on VMware, which is your private cloud, and you can do on public cloud, and you can have a multiple public cloud as well. Your one, say you're creating a basically a web service. I will take a very simple example of WordPress website. So you have Apache MySQL and web server MySQL and one DB server, right? So you can have your web server running on Amazon and your database running on Google Cloud Compute. And in that way also you can do that kind of something like you want to really fancy on to distribute your all effort. So these are very good way of doing that. Any more question, anybody?
So before you wrote this script and deployed the VM, you must have already connected to your AWS.
No, I just right now you connect and disconnect each time. So this time, the moment I type it here, now I have no connection with this. So the moment I do, now it's invoke the Boto library and now it connects. So if you go here, and now see it's creating. So before that, I had to do something. I had to create an AMI key. I had to import SSH keys. Yes, of course, few things you have to do, because before you allow this Ansible code to be accessed Amazon, you have to enable certain keys, so that because it cannot let everybody access it. Otherwise, what is the point of security? So it's not the connection, you have to set up the keys.
That's from Ansible though, not from AWS.
No, that is from AWS actually. You have to go to AWS, like go to AWS and basically AMI key, you create the key. And similar thing if you, I think I did one of the another on using how to use AI services like sentiment analysis or machine learning feature. Similar way you can use Amazon, and you can use, I use in that example Python. So you can use any programming language, Python, Groovy, Java, whatever you like. They support pretty much everything. So this is the example, and similar way you can delete also. Like terminate is also very simple. You just give the instance ID and this is a very primitive example, but it's very good to start on. So you create your own, delete your own, build some confidence, build some environment, do something. This is on, mostly I'm talking about infrastructure side of DevOps. But if you want to get more comfortable with, build side of it, doing some kind of building Java code or using Artifactory, Jenkins, that is another kind of thing. So I'll say don't jump on everything at the same time because you will end up nowhere. So just focus on certain tools. Say now you are interested in Ansible. Just focus on Ansible for a couple of months. Then you'll get some understanding. If you think that in 1 hour you'll become Ansible champion, imagine if that was so easy. Even I don't think even driving is that easy. Cab driving is very difficult. You need to do license for 1 year. So I mean, if it was that easy, yeah, nobody will pay you any money anyways, right, for that. So simple. But it is not that difficult. I will say you have to have at least 1 or 2 months before you can say you will be very comfortable with Ansible. Does that answer the question?
Yep.
What is the infrastructure failure? What are the infrastructure failure models? There are many failure models depending on what kind of environment you are working on. So infrastructure failure, maybe I'm not getting the question. Like you're talking about, someone asked Gordon NK. So usually any kind of where you want to have a highly available, I think maybe you're talking about this thing, HA model. So if you're having any kind of highly available resources, so you have to come up with two. Like you can use, Amazon comes with automatically, they call it Amazon auto scaling. What they do is they create virtual machines in different data centers. They call them region. So basically they have a Montreal center. So you take your virtual machine, you create one VM in Montreal and you create one in Ohio and you replicate them. And Amazon does it for you without doing anything, at extra cost. So it gives you a highly availability feature. And plus you can have the Amazon Gateway API. What it does is it keeps that whichever node is active, it will transfer the traffic towards that. Whatever is down, it will not transfer. So I can maybe next time I will take an example of this. And also, if this is the Amazon way of doing it. But if you want to do it your own, you can actually try with Kubernetes. Kubernetes comes out of the box, this kind of feature. They call it service and the pods. So you have, say, 5 pods. Very simple example. You have your website running. There are 5 web servers running. And if any of the web servers is down, it will stop giving traffic to that particular one. And instead it will write out the traffic to the one which is alive. And meanwhile, it will restart and spin up a new pod for you to take the load. So that works on a HA perspective, as I said. Like HA means highly available. And also it helps you to have a feature, something called cloud burst. Cloud burst means, say you have, like take an example, say Amazon. On say Black Friday, they go crazy. Okay, DR. Disaster recovery, yeah, that's what I said. Your auto scaling may be able to have disaster recovery, and you can have many ways of disaster recovery. You can have your data. There are 2 things you have to see: compute disaster recovery and data disaster recovery. Compute disaster recovery, you need to have enough horsepower, like enough EC2 or compute power, maybe in a form of Lambda or form of EC2 that can replicate. And second is the data. Data you can actually store in a third party, or you can put in as a S3 bucket, so that if anything is going down, you can keep it. So this is a very big topic that you're talking, disaster recovery. You can achieve disaster recovery at application level. In that you have application to application replication, like your MySQL replication or Kafka cluster or Elasticsearch cluster. That is I will say a replication available from the software side. As an IT guy or as an infrastructure guy, if you want to have, what you do as a disaster recovery to replicate the boxes. So I have say 1 cluster of say MySQL DB with 2 replica node, and I can create an identical somewhere else also and have a load balancer at the top of it. If my active one goes down, the backup or a disaster recovery will take off. And you have to have constant sync between active and the backup, so that anytime if the active is down, whenever your application connects to the backend, it doesn't see someone new has joined. For it is the same thing. So it is a more of a, I will say, this is called 3-tier application structure in the software delivery model. Before you have a application server and database. So now we have a application server, web server, and database. So these are 3-tier architecture, should be able to do it. Any other question?
One last question for me from maybe. So let's say there's several servers in the DevOps, like currently DevOps infrastructure, and if you need to patch all of them, is it ideal for patching the servers using the container tools, or?
Yeah, patching is a word. It's actually a very good question. Patching is the classic use case of configuration management. So if you want to do, say, patching, say you have, and now it doesn't matter, you have 2 Linux boxes or 100 Linux boxes. What you do in an Ansible world, you write a role. First you test it on one box, everything is working, and then you just blast it over all the whole cluster. So basically at once it will patch all the 10-20 servers. So same object you can achieve using Ansible. So Ansible will be, say, I will say role. Assume this example, say here. And I think if I want to do that, I have another example maybe. This one, let me show this one. Yeah. So say I have the inventory. I can just do a here, like something like that. You know, I do a here. I say tasks. And I do a yum update. Assume. Just I'm saying yum. I will say update. Name equal to star. It means star all packages. State equal to latest. So this what to do is, and just very primitive example. Right now what will do, whatever the EC2 boxes I created, it will do a yum update on all of it. You can make it a bit more complex. You can want to update only maybe security library. You want to update only SSH libraries. You can customize as you go. Does it answer your question?
Yep. Thank you.
Okay. I think if no other questions, so we can just wrap it up. And anything else? And I think, yeah, I would like to also, Hiren, are you still available? Maybe you can talk about the Jenkins thing that you did, if you have time, or we can just wrap it up.
Sure, I can talk about it, like why the financial institution that I was working with went with Jenkins pipeline and Bitbucket to begin with. Like as Ashish said earlier in the question, that all these things are so complex. Where do we begin from? And the drive actually comes from what is the business need or DevOps and everything. The typical problem that one of the client that I was working with was having is like, imagine when you buy a stock or a bond or currency, like basically when you do any trading, there are so many systems involved before the data resides in the target system. So imagine you buy a stock till you get the bill. There are so many systems involved. And the requirement was to validate data at each and every step of the system. So what they were doing was they were only validating data in the target system. Now, before data reached there, it was enhanced, transformed, and traversed through several layers. So to backtrace the issue was costing lots of resources in terms of time and money. And as a result, what was happening was they were not able to do frequent releases in the production environment. And it was costing business tons of money. Now imagine to debug one simple problem, like why the data like is looking in a certain format or in a certain way. It took them nearly 4 days to isolate the problem. The ask was to go from 4 days to few minutes. And I was responsible for designing the solution and I used a Jenkins pipeline because some of the systems or some of the testing that they had was using HPALM tools. Then the unit testing was happening in the Java JUnit test cases. And the ask was to combine all these things together for end-to-end integration testing pipeline. And the systems involved were like varying system. Like imagine you book a trade, so you have HPALM tool involved, which was pretty much in use, and they don't want to move away from it. So the challenge was what client has got to begin with. Now, do they have a version control? Yes, they do. Where? In Git. So, okay, do we want to trigger the test case based on whenever the code is checked in? But here we have multiple systems. So how do we integrate all these things together? Those were the challenges. But the systems involved at a high level were like MQ. So when you book a trade, first thing is goes with an MQ. Secondly, it will go to, say, Kafka. NoSQL database like Elasticsearch. And finally, the data resides in a target system called KDB or KDB database KX system. So how do we integrate booking a trade till verifying data at all these different systems and automate this and provide the flexibility not only to business but to developers to frequently initiate or trigger the pipeline and test the code at each and every layer. So the first system is MQ, okay, we are happy, data coming in, data coming out, becomes input to the second level, which is Kafka, the third level, which is Elasticsearch, and finally the target system. So as a result of the Jenkins pipeline, we run the test across each of the system, and if anything fails based on the criteria defined by business and the testers, then we know that yes, we cannot move any further because we have a failure right in the first system here itself. So that way Jenkins was very useful. And secondly, business wanted to see the test cases, like what is failing, how it is failing, and want to look at it online or preferably online, like previous test cases as well, like what was the test result. So all this complex requirements of availability of the test result, test data, what happened in the past, which system is behaving awkwardly or which is not behaving very well. So Jenkins gave us a very thorough, complete analysis of all the test cases involved. And from 4 days of debugging a problem, we just brought it down to 4 minutes, which is still a lot of time, by the way, 4 minutes, to complete end-to-end test cases, integration test cases especially. But we are working on it, like how do we bring down from 4 minutes to few seconds. But imagine from 4 days to 4 minutes, lots of success, and we will continue working with how can we effectively and make the Jenkins pipeline very efficient. And this is just Jenkins compiled, by the way, guys. And so to begin with DevOps, in a nutshell, what is the business requirement we are looking at? In our case, bring down the debugging of the problem, solve the problem, isolate the problem, and then provide flexibility of frequent builds by just pushing or initiating a Jenkins pipeline. Any questions? No questions? Bad.
Yeah, okay, cool. So thanks everybody. Whoever joined from YouTube, please feel free to subscribe to the channel. And anybody came up from Toronto AI meetup, please feel free to look up for our next meetup. I think next webinar we'll have on AI sentiment analysis, doing on AWS, and also we'll talk a little bit on R. And thanks everybody, and see you again.